Hi everyone, today we'll go through the problem lucky numbers in a matrix. We'll go through the problem statement first. So given that M cross n matrix with M rows and n columns, which has distinct numbers in it, and we need to return all the lucky numbers in the matrix in any order possible. So what's the lucky number here? So a lucky number is an element of a matrix such that its minimum element in its row and the maximum element in its column. What does it actually mean? So I'll just go through the intuition and then we'll code. If you see here, given a matrix as follows: 3, 7, 8, and 9, 11, 13, and 15, 16, 17. We are told to find the lucky numbers. And he defined lucky number is a number which is minimum in its corresponding row and maximum in its corresponding column. Okay, we need to check this particular value should be minimum in this particular row and should be maximum in this particular column. If so, then this is a lucky number. But if you see here, this is minimum in this particular row, but not maximum in this particular column. If you write the minimum values for this particular row, it's 3, it's 9, it's 15. The maximum value in this particular column is 15, 16, and 17. Okay, we need to find lucky numbers in the matrix and then return them in a list. How we can find? See, we'll find the rows minimum and columns maximum. How? We'll iterate to the matrix. We'll go through all the rows. For I in rows minimum dot append minimum of I. In this way, we'll find the minimums of all the rows. We'll get 3, 9, 15. We'll get 3, 9, 15. As so we have did to find the row minimum, we'll do the same to get the column maximum. We'll in range of columns, we'll find columns maximum dot append matrix of maximum of matrix of I. Maximum of matrix of I. Here J. J is a column. You're getting it right? We'll try to find the maximum in that particular column. Okay? And we'll get 15, 16, 17. Okay? Once we get this, we will iterate through the matrix for I in rows, for J in rows, columns. We'll find matrix of I comma ij is double equals to minimum of minimum rows. We have already find out the minimums in particular rows, right? I is a particular value in that particular row, and also this particular value is same with the column max. We'll just check. The corresponding column is J. So we'll just check maximum column of J. If this is the case, append it to the result. In this way, we'll find all the lucky numbers and then we will return the result at the end. You're getting it right? First, we'll find the row minimums and then we'll find the column maximums and then we'll try to get the lucky numbers which match with this particular row minimums and column maximums. Okay, let's code. So if you see here, we will initialize two lists, row minimum which is empty now and column maximum which is empty. And now we will find the row number of rows, length of matrix, length of columns equals to length of matrix of 0. Okay, we'll now iterate through for I in range of rows, for j in range of columns. I'll take for this particular row a minimum is n star star 9. At start we are not sure what's the minimum, so I'll initialize it with the maximum number. And now I'll iterate over the whole row. Row minimum is minimum of row minimum, comma, matrix of I, j. Okay, this is how we'll try to find the minimum value. And after iterating through the whole row, we'll append it to the row minimum dot append mini will write as minimums dot append row minimum. Okay, and we'll do the same for columns as well. So column maximum is max of column maximum, comma, matrix of, we need to go through j and I. Okay, now we'll append the results, column maximums dot append the value column maximum. Okay, we have done the row minimums, we have done the column maximums, and we have got this. And now we will iterate through range of rows for j in range columns if matrix of I j double equals to row minimum of I and matrix of I j double equals to column maximums of j, will have a result list result dot append matrix of I j, and we will return the result. So I'll just run this. Is not defined. Oh, columns maximums I have. I'll just change it. Column maximums. Okay. Now I'll try. List index out of range. Y O I and J. Row and column. You see here? These all passed. If I show you the row minimums, print row minimums is row minimums, and I'll print the column maximums is column maximums. So I'll just print it so that you'll get to know. If you see here, the row minimums for the example 1, 3, 9. For the row 1 it's 3, and for the row 2 is 9, and the row 3 is 15. That's what we got here. And the column maximums are 15, 16, 17. And we are trying to match it. When it's a match, then append it to the result. I will comment down and submit the solution. If you see here, the solution got accepted. The overall time complexity is O of n square. Actual time complexity of is O of 3n square, but we'll go with worst case time complexity. So we'll remove the constants, right, in big O notation. So it's O of n square. If you have any issues, please comment them in the comment section. Please like, share, and subscribe.